Today I want to give you a little bit more details. Well, I didn't time myself, which I knew was going to be a problem. Oh, you're doing it. Thank you. She's great. So I wanted to give you a little bit more details into the AI Cyber Challenge. For those of you that were there for the keynote yesterday, Perry Adams talked to us about the AI Cyber Challenge. I wanted to give you a little bit of inside perspective from one of the competitors' teams. So the qualifications event just finished. The program was announced like a year ago, but we got drips of information over time. And I didn't mention it, but I'm on Team Shellfish. So Shellfish is a large hacking competition. And the winners were kind of, we were dripped information during DEF CON. So the winners were officially announced Sunday. But from Friday to Saturday, this was all the information we had to go on. The information on the left is these achievements unlocked, which was basically a first blood. So whose cyber reasoning system was the first to identify a vulnerability, and whose CRS was the first to patch a vulnerability. Of course, you may think this is great. I bet these teams were like partying and like really thinking that everything's great. The problem is, scoring had nothing to do with how fast you're able to do anything. So even though we had this information of who was first doing what, we couldn't actually use that in order to understand our score in the competition. So it was all about for every challenge problem. So here there were 5 challenge problems: the Linux kernel, Nginx, SQLite, Jenkins, and Tika, which is a Java program. Each of those challenge problems, every CRS had 4 hours to run and $100 of LLM credit to try to identify as many vulnerabilities as possible. Not only figure out what the vulnerability is, but what commit out of roughly 100 to 200 commits introduced that vulnerability, and then generate a patch that not only fixes the vulnerability, but doesn't impact the functionality. And so the only thing we had was this global view on the right, which again also makes you terrified because you don't know if any team, this is just a global overview of if any team unlocked that information. And so Shellfish was one of the 7 teams to qualify, which was awesome. We still don't know, as you see, this is a alphabetical ordering of teams. We still don't know if we just barely snuck by with 7th or if we should really be happy because we got first, but honestly, it doesn't matter. We're happy to be invited to the party. And we should be finding out more information about the exact details of the competition. And so I wanted to talk a little bit about our approach that we took during this competition. So our CRS is called Artificial. That's the logo on the bottom of that slide. And we really base this off of, actually I could even say that a significant chunk of our CRS is open source, although the significant chunk is that foundation without which we have nothing but doesn't do anything by itself. This is a PyData task, which is with Audrey on our team, also known as Relmot. If you know her, she is a core Anger creator and all around just like amazing person. And she created this crazy orchestration framework where you can define different components and define a pipeline of jobs going in and out. The cool thing is you can run this on a 3-node Kubernetes cluster, which was like what we had in the production of the competition, while also running the exact same thing on your local machine using whatever resources were available here. So it's actually, I mean, I thought this was like crazy when the students were telling me about how this system worked. And then as I dug in more and more, I got to understand like, oh, this actually like kind of does work. So because of this, we generated, this is one of our older versions of our pipeline. So we had all these little kind of services that did stuff and took in input. And again, this is another thing that was crazy because you had to work on general C targets, Java-based targets, and the Linux kernel, which all require completely different interaction, different components. So trying to get the data from one part to the other was challenging and difficult to be able to run on all of these. I'm not going to talk about how these individually work because I don't want to give away any of our secret sauce. But I can say at a very high level, the key question everyone wants to know is, were LLMs useful? The answer is yes, but not probably as much as you think. We're not going to get overrun with LLMs taking away our jobs yet. They are very good at certain things. Specifically, we used like a hybrid style approach where we had fuzzing and other types of analyses to try to concretely identify vulnerabilities. But the LLMs were great at patching. That's actually the thing that we found. So super interesting, and I'm getting dragged off the stage, so thank you.